Welcome back to the session. I, Dr. Indu TK. You have been watching my videos on Geography of India. Today, we can discuss the captivating world of the Indian monsoon and its interactions with two fascinating climatic phenomena, the El Nino and La Nina. These phenomena are a part of larger system known as El Nino Southern Oscillation or ENSO. They play a big role in shaping weather pattern not just globally but especially here in India. Understanding how El Nino and La Nina affect our monsoon season is key because the monsoon bring essential rain that our farmers rely on, and they influence everything from water supply to our daily weather. So, let's explore together how these powerful forces in the atmosphere impact our world and our life. El Nino and La Nina are complex weather patterns resulting from variation in ocean temperature in equatorial Pacific region. They are opposite phases of what is known as El Nino Southern Oscillation or ENSO cycle. The ENSO cycle describes the fluctuation in temperature between the ocean and atmosphere in the east central equatorial Pacific. El Nino and La Nina episodes typically last 9 to 12 months, but some prolonged events may last for years. El Nino is a climate pattern that describes the unusual warming of surface water in eastern tropical Pacific Ocean. It is the warm phase of a larger phenomena called El Nino Southern Oscillation. It occurs more frequently than La Nina. La Nina, the cool phase of ENSO, is a pattern that describes the unusual cooling of the tropical eastern Pacific. La Nina events may last between 1 and 3 years, unlike El Nino, which usually lasts not more than a year. Both phenomena tend to peak during the North Hemisphere winter. Now, let us understand the ENSO cycle. El Nino Southern Oscillation or ENSO cycle is a repeating climate pattern that occurs over the tropical Pacific Ocean. Typically, the tropical Indian Ocean experiences low pressure while the tropical South Pacific Ocean has high pressure. However, these pressure conditions can flip, leading to what we call the Southern Oscillation. This flip-flop in pressure happens every 2 to 7 years and causes significant changes in temperature and rainfall patterns. These changes disrupt large-scale air movements in the tropic. The El Nino phenomena is linked to these shifting pressure conditions in the Pacific and Indian Ocean. The ENSO cycle consists of 3 phases. The first phase is El Nino. It occurs El Nino time. When there is an El Nino event, the trade winds weaken or even turn around, allowing warmer than average water to migrate into central and eastern tropic Pacific Ocean. Second one is La Nina phase. La Nina is characterized by cooler than an average sea surface temperature in the same region. It occurs during La Nina time. The water circulation gets stronger during La Nina event with more convection across the western Pacific and stronger trade winds. The third phase is ENSO, the neutral phase, where the conditions are neither El Nino or La Nina but rather neutral. Trade winds move east to west over the tropical Pacific Ocean surface when the Pacific Ocean is in neutral condition, bringing warm, moist air and warm surface water to the West Pacific while keeping the central Pacific Ocean relatively cool. In comparison to the east, the west has a deeper thermocline. Each phase of the ENSO cycle brings predictable changes in the weather patterns affecting everything from rainfall to temperature across the globe. Now, we will discuss the impact of ENSO on India. Weather and climate patterns such as severe rainfall, floods and drought are all influenced by ENSO. El Nino causes global temperature to rise and La Nina causes global temperature to fall. El Nino is linked to dryness and a poor monsoon in India, whereas La Nina is linked to a robust monsoon, above average precipitation and cooler winters. El Nino, which is marked by an increase in Pacific Ocean surface temperature, is linked to lower than normal monsoon rainfall in India. El Nino disrupts the flow of moisture-bearing winds from cooler waters towards India, wreaking havoc on the summer monsoon, which accounts for more than 70% of annual precipitation. An El Nino of any severity can diminish monsoon rainfall and consequently have a big influence on the local economy. Both the surface and deep ocean temperature are rising, indicating that the mild El Nino will continue for at least the next several months. The rainfall in Southeast Asia during the La Nina year is more than normal in northwestern India and Bangladesh in particular. The Indian economy, which relies on the monsoon for agriculture and industries, benefits in general. In India, it generally delivers colder winters than average. La Nina's chilly air, which is connected with this north-south trough, tends to spread further south towards India. So, what exactly is El Nino? El Nino is a Spanish word that means little boy or Christ child. In 1600, South American fishermen observed the episodes of exceptionally warm water in the Pacific Ocean. El Nino usually peaks in December. El Nino may have a big impact on our weather. The Pacific jet stream is moving south of its neutral point due to the warmer seas. The northern United States and Canada are drier and warmer than the typical as a result of this change. However, in the Gulf Coast and southeast of United States, these seasons have been wetter than typical, resulting in greater floods. Now, let us discuss about the formation of El Nino. In the central and the eastern tropical Pacific Ocean, there is a warming of the ocean surface or above the average sea surface temperature. Rainfall tends to decrease across Indonesia, where it arises over the central and the eastern tropical Pacific Ocean. Low-level surface winds, which typically blow from east to west near the equator, the decrease or in certain circumstances reverse direction. In general, the greater El Nino is warmer the ocean temperature anomalies and vice versa. Now, let us discuss about the effects of El Nino in India. El Nino effects in India is mostly negative, as the Indian monsoon and El Nino are inverse to one another. It weakens the monsoon and causes monsoon failure many times. The first major El Nino effect is lesser rainfall. The average precipitation in India is 120 centimeter, but during El Nino year it reduced drastically. El Nino droughts have caused 6 of India's most notable droughts since 1871, including the most recent one in 2002 and 2009. In India, the rain-fed agriculture covers about 50% of the land area under cultivation, and a good southwest summer monsoon is essential for Indian crops. The failure of monsoon causes water shortages and below average crop harvest in several areas of India due to El Nino effect. Major drought-prone areas like Maharashtra, northern Karnataka, Andhra Pradesh, Odisha, Gujarat and Rajasthan face the El Nino effect. With the monsoon failure, India faces high inflation and slow GDP growth. Weak monsoon also contribute to lower hydropower dam power generation, which result in even lower electricity for irrigation needs. The crop yield is further decreased by this. However, not every El Nino year affects India. For example, even though the years 1997 and 1998 were notable El Nino years, there was no drought. Now, let us discuss about the history of El Nino events. For the last 300 years, ENSO conditions have occurred every 2 to 7 years, but the majority of them have been weak during 1789 to 1793. According to a recent study, a strong El Nino effect might well have contributed to Europe's poor crop harvest, which in turn may have sparked the French Revolution during 1876 to 1877. The deadliest famine of the 19th century were caused by the harsh climatic condition brought on by El Nino, and it is expected that up to 13 million people perished in the northern China famine of 1876 alone. In 1892, Captain Camilo Carrello told the Geographical Society Congress in Lima that Peruvian sailors gave the warm south-flowing current the nickname El Nino, since it was most evident around Christmas. This was the first time the phrase El Nino was used to describe the climate. The scientific community's attention increased as a result of significant El Nino effects. During 1997-1998, it was the first El Nino episode that was meticulously monitored from beginning to end and compared to the typical increase of 0.25 degrees Celsius brought on by El Nino episode. The event momentarily raised air temperature by 1.5 degrees Celsius. In 1997-1998, El Nino affected 16% of world reef system and killed most of them. These year events resulted in the persistent drought condition in Indonesia, Malaysia and the Philippines. In California and Peru, there have been reports of flooding and heavy rain. Next, we will see what is La Nina. In Spanish, La Nina translates to little girl. The impact of La Nina is the polar opposite of El Nino. A more severe hurricane season is also possible as a result of La Nina. In the central and eastern tropical Pacific Ocean, there is a cooling of the ocean surface or below the average sea surface temperatures. Rainfall tends to rise across Indonesia, whereas it tends to decrease throughout the central and eastern tropical Pacific Ocean. Along the equator, the typical easterly winds grow much stronger. In general, the strong La Nina is the cooler the ocean temperature anomalies and vice versa. Now, let us see the formation of La Nina. Trade winds are greater than usual during La Nina occurrences, bringing more warm water toward Asia. Off the west coast of Americas, upwelling occurs, sending cold, nutrient-rich water to the surface. The jet stream is being pushed northward by the chilly seas in the Pacific. Droughts are common in the southern United States, whereas severe rainfall and flooding are common in Pacific Northwest and Canada. Winter temperature in south are warmer than average, while the winter temperature in the north are cooler than the typical during La Nina year. Now, let us see the impact of La Nina on Indian monsoon. Conversely, La Nina events usually enhance the Indian monsoon. The cooler Pacific Ocean temperature reinforces the atmospheric circulation that brings more moisture and rainfall to the Indian subcontinent. This can lead to above average monsoon rains, which, while beneficial for agriculture, can also cause flooding and other weather related challenges. Understanding the effects of El Nino and La Nina on Indian monsoon is vital for effective climatic prediction and preparedness. These phenomena influence various aspects of India's climate and weather, which in turn have far-reaching implications on multiple sectors of society. During El Nino years, the weakened monsoon can result in drought which severely impact the crop fields. This not only affects the food security but also the livelihoods of millions of farmers who rely on monsoon rains for irrigation. Conversely, La Nina often leads to abundant rainfall which can be beneficial for crops if managed well. However, excessive rainfall can also lead to flooding, waterlogging and crop damage which disrupt the agricultural activities and affect the food production. El Nino can cause droughts and can deplete water resources, leading to water scarcity in many regions. This impacts drinking water supplies, irrigation for agriculture and hydropower generation, creating widespread socio-economic challenges. While La Nina typically brings more rainfall which can help replenish reservoirs and groundwater levels, it can also cause floods. Managing the excess water to prevent damage to infrastructure and loss of life becomes a critical task. The economic impact of El Nino induced drought is significant. Reduced agriculture output can lead to increased food prices, affecting both rural and urban population. Additionally, water shortages can hinder industrial activities and reduce hydroelectric power generation, affecting overall economic growth. The economic effects of La Nina can be mixed. While good monsoon rain can boost agricultural productivity and reduce food prices, the risk of floods can lead to substantial economic losses due to damaged infrastructure, disrupted transport networks and increased spending on disaster relief and rehabilitation. Monitoring and studying the patterns of El Nino and La Nina are essential for effective climate prediction. Advanced forecasting techniques can help predict these phenomena months in advance, allowing government and communities to prepare for potential impacts. Preparedness measures include agriculture planning, advising farmers on crop choices and irrigation practices based on predicted rainfall patterns. Second one is water management, implementing water conservation strategies during El Nino years and flood control measures during La Nina years. The third one is disaster management, strengthening disaster response system to mitigate the effects of drought and floods. Next is the environmental impact. The influence of El Nino and La Nina extends to natural ecosystem as well. Altered rainfall pattern and temperature changes can affect biodiversity, forest health and freshwater ecosystem. Understanding these impacts help in the conservation and management of natural resources. The study of Indian monsoon and its interaction with the ENSO cycle is essential for building a resilient and sustainable future. By leveraging scientific advancement and integrating predictive insight into policy making, we can navigate the challenges posed by these climatic events more effectively. This proactive approach not only safeguards our communities but also promotes long-term sustainability and economic well-being. That wraps up today's section. I hope you found it informative and engaging. Your participation is crucial in our collective effort to understand and respond to these important climatic phenomena. See you all in the next series. Until then, goodbye.